to be able to get back to this seminar and to get answers to some question. The first question is what the type is. So let me ask this question for you. What the type is? Previously we answered not this question. In the meantime, I will open the appropriate project. So now, for all of you that you are using Visual Studio and trying to follow me on the Visual Studio, I have opened the first folder, Introduction, and now I'm exploring the Introduction unit test, this project. In this project, there is a file, Roman type concept, and this way I'm getting back to the concept, getting back to the abstract discussion about the Roman and about the Roman representation. What is the Roman number? But before starting discussion about the Roman number, you're trying to answer the question what the type is. Not now. The next question: what values are in the Roman type? It is my next question. Have you got this question? Just a second. Oh, there's something wrong with my computer. No, how it works. Okay. What values are in Roman time? But get back to the type and answering to the question about the type. On the screen, we can see that here we have a variable. It is variable, so it's a value holder. Actually, we can assign to this value holder a value. On the right side, we have a value. Actually, what is on the right side is question for you. Try to answer in your brain. In the meantime, simultaneously, but I'm not going to answer this question. I'm not going to ask this question on the chat, but on the left side, in front of on the variable, we can an identifier. In this case, it is keyword, and after hovering by the mouse, we can see that its structure it is system int 64, but still it's type. So answering the question what the type is, I think that the answer we can get from the definition, because it's type, definitely it's type, but what the type is and how it relates to the code, because previously during the lecture we discussed the term code, what the code is, and as you remember, the code is representation. It is three things: alphabet, syntax, and semantics that describe representation of the data, representation of the information using the data. Here Visual Studio provides us F12 key and many entry. Go to definition. So go to definition, and we can see that type is, in this case, it's structure. Here we can see that it is definition, so it's structure. But additionally, it is not only structure. Additionally, here we can see that there is a lot of operations. Therefore, we can answer this question that type, it is set of values, well-defined set of values, and well-defined set of operations on these values. It is type. It is very important, I think, definition, because we are using types. In all of the languages today. Therefore, it is very important that you know this term. That is set of values and set operation of this on these values. Because we are talking about the machines, we are talking about the computers, the set of values must not be infinitive. It must be limited. So the number of members of this set of values is limited. Of course, it depends of the type, but still in all of the cases it is limited. It is, of course, sometimes we can add new values to this set, but still possibility it is always is limited because we are talking about the physical machines. So if we know what the type is, let's ask what the simple type is. What is simple type? Just a second. I try to put this question on chat. What is simple type? Let's get back here. You can see that in this it is statement. Actually, it is assignment statement because we are assigning a value. On the right side, I asked previously what this in context of the in terms of the language. It's expression. It's expression, and this expression can be evaluated as number 4. And we are assigning the value to the variable, to this variable, and this variable its type. So what the type means in this example? The type in this example mean that it is a limitation of this limitation of the value. Of the limitation of the variable. Actually, it is limitation because it limits the value. So it limits what we can assign here for the value. Second, it limits also the list of operations we can execute against this value. So in this we are talking about the variables and talking about as a value holder. We are talking about the types as a limitation that allows us to assign value. Okay, but on the right side we can see that is number 4. But let's write something like this. You can recognize this text. It is just a text, but you can recognize it. You can think about this. You can assign to this text a value, and the value is also the number 4. But now there is an error, and actually the error. Not sure if I can enlarge it. I'll try me to enlarge it. It doesn't work for the virtual machine, so I cannot enlarge. But we can. Let me read it. Cannot implicitly convert type double to long. An explicit conversion. Use your are you missing a cast? So let's forget what the cast mean. But do you think that is problem with conversion? Are we going to convert something here? No, of course no. Now we are going to assign a value to the variable, not convert. So we are not trying to convert something. So the feedback from the design environment, it's something not very clever. I think we must try to find the answer in a different direction. Actually, we must answer on the question on the right side of this assign character is, as I said previously, it is expression. So it is operation. Let me ask you next question. Is just operation? Some people complain that must answer the question and listen listen to the lecture at the same time, but it's as usual. Sometimes we need to simultaneously do the same and share our brain for different things at the same time, but forgot about it. Driving, for example, and trying to send SMS at the same time, it's stupid. But this way, it's thinking about two things at the same time sometimes is required, and is an example how to do it. It is an example of this approach. So actually, still we are trying to answer. Still we are trying to assign the same number 4. So we know that this number can be assigned to the value, to the variable, because it is inside of the set. The set contains also number 4. But the problem is that we are assigning a type not to the value, but to the expression. On the right side, there is expression. And it says that the syntax of the value defines the type. And actually, the type, it says that it is double. It means that the expression is of type double, not of type long. Therefore, next question is, if all of the types, all of the values that belongs to the type on the right side can be assigned to the variable limited by the type, limited by this type, by long. Of course, in this case, no. For example, if we change it to this number, we can say definitely that it is outside of the set of allowed values that can be assigned to this number. This number must be integer, but 4.1 is not integer, but still the error is exactly the same. Therefore, we must understand that type, it is just a set of values. And actually, if we are getting any errors related to the types, we are getting the errors that relate that it's impossible to assign all of the values that belongs to one type to the value, to the variable that it's limited by the second type. But on the right side, we have expression that is double, and on the left side, there is long. Of course, it is the only rule, and actually, this rule it's in many. This rule is in many. It's in many languages. In many languages, the same. For example, let's try to uncomment this, and you will get exactly the same error, because now we are trying to assign the float. On the right side, the expression is float. Doesn't matter that the expression is written in the program as a constant, but the syntax of the constant actually defines the type of the expression, and the expression must become compatible. It means that in all of the cases, because the expression returns only one value, in all of the cases, it should be possible to assign the value from the expression to the variable. In this case, sometimes it is impossible. Therefore, we are assuming that always it is impossible. Of course, sometimes it's possible to say the compiler that it is, for example, integer. And after saying that it is integer, it is possible to assign, so we are converting actually the type. We are still talking about the text. It is still program. We are not executing the program. We are not converting something. We are not doing something. We are just talking about the text. Therefore, talking about the text, here we are saying the message to the compiler, because the compiler works under the cover, under the hood. We are saying to the compiler, okay, we are treating this expression as integer. Finally, we are getting the integer number, deal with it. It's your responsibility to assign the value. Do what you like, but for us, the most important thing is that the value is correct. It means in this context that it's correct because it assignable. So it is inside of the set of the type of the variable. Therefore, it is very important to note that we have set of values, well-defined set of values for each variable. Each variable must have well-defined. Of course, as a side effect, we are this way. We are trying to say something about the memory we need to hold the value. We are talking about the syntax and semantics of the value, because at the end of the day, the value will be binary, will be written, will be saved in memory as a binary value. Therefore, here we are talking also about the code. You are defining the code, but because writing the text of the program, you are not talking about the physical representation of the computer. We can forget for a while about the binary representation. Therefore, we must forget for a while about any representation. Doesn't matter if it's binary or no. Therefore, we are talking about the language. We are talking about the rules of the language, and we are trying to use the similar rules as in the native language. Because the problem here is, if it's not true, we said that it's integer, but if it's not, what happens if it's not integer? This way, you can see that, because in any case, after switching off the IntelliSense, in all of the cases we will not get any error, any response from the design environment. And in this case, of course, for the design environment, the most important thing is that we are declaring something. We are saying that it is integer. Doesn't matter about the syntax. Forget about the syntax. For us, it's integer. Finally, it will be integer. But if it's not, we'll get an error during the runtime. Let me recall that we have two very important phases, very important stages of the software life cycle. It is design time, where we are talking about the text, and is runtime, where we are talking about the about execution of this code. Sometimes IntelliSense and other tools that are used inside under the cover of the design and design tools simulate execution and actually provide feedback that actually it relates to execution. So in this case, it is also execution error. Especially this, it is execution error. But in this case, we are not getting any answer, any feedback. But here, it is so the environment tried to simulate execution and try to help us to avoid any runtime errors. It is very important difference. It is very important difference. For example, if you are writing a software for the rocket, for example, or for the car, or for something, for device. Previously, I had a topic related to mobile devices. So the difference is that if you are getting an error during the compilation time, during the design time, it's just a second to fix this error. If you are getting errors during the runtime, you can expect, for example, that the rocket will hit you inside of your target. It is completely different. It's completely, so the error could be very simple. But remember, we are not able to measure simplicity. It's impossible to measure simplicity. Therefore, it is wrong to say that something is simple or not. It is simple error or not simple error. Of course, we can talk about the typo or no typo. Typo it's an error related to the. So here, for example, we can say, okay, it's typo, because we can change the text. In this case, it is very important runtime error. Okay, but let's get back to the Roman. Previously, I said so the answer. So what value is in the Roman time? Of course, the Roman type. We should expect that the Roman time contains integers. Actually, unsigned integers, but representation in the native language of this Roman numbers, it's someone could say it is strange. Of course, it's not strange. It depends on the code. It depends on the syntax. It depends on the number system you are using. But still, we must have in the program some freedom to use custom types. For example, to use representation like Roman integer. Of course, one of possibility is to use a free string. So it is a string. It is series of characters. We can distinguish first characters and last characters, and for each character we can distinguish the previous one and the next one. It is the series. It is the sequence of characters. So you can use the sequence of characters to represent a Roman integer, but we should expect to, for example, to provide unit testing and to provide appropriate operations, to provide expression. Not sure if it's somewhere over here. Okay, let's try it next time. But here you can see that we can write it. We can write it as a string, but here actually it is. We can provide any text. And in previously, we are talking about the Roman representation of the integer. In this way, we are talking about just a text. It means nothing. It's impossible to provide any meaning. But we are expecting to provide the meaning to the number. So we must do something, and the answer is here. We can define a custom type. So in any case, we can define a type that provides our own set of values and set of operation. So let me ask next question, because previously I asked you what the simple text, what the complex type is. So let's answer the next question. It's difficult, probably, for you. What is the structure type? It is important for task 1, therefore I'm asking about it, and the next question is also related to the task 1. So try to answer it to make sure that you can resolve the task according to the expectation. Get back to the Roman type. Here you can see that we have a Roman. It is a type because it's in front of the variable. We can recognize it in the assignment statement. So always assignment statement in all of the languages has similar syntax. So we have a type, we have variable, name of the variable. Usually we are calling it as identifier because it contains only the letters, numbers, and underscore. Must start from the letter or the underscore. But it's in identifier. It represents the holder of the value. Any questions? Because I can. There's someone that switch mic. If you need to interrupt, just do it. Don't hesitate to interrupt me. I hope it is better to interrupt me now than now get back to some discussion. Do the previous discussion. Okay, so let's see on the next line. In the next line, we can see, well, no, I'm not sure if it's well known for all of you, because we are in front of the next in the project lesson, and during the project lesson probably we'll learn the answer are equal function, but it means, so let me now explain what it means. It means that we are comparing two things. We are comparing this entity and this entity, and here we are saying what type we are expecting this entity are. So here we have a constant number 4, and here it's a variable of type Roman. Therefore, we can see that it's not like expected, because we are expecting integer here, but not Roman. So the question is if the Roman is compatible with the integer. Let's go back to this definition. So we can recognize type that are different but compatible. Compatible means that that the set of values are has common part. So the type is compatible if all of the values belongs also to the set of the destination type. If we are talking about the long and about the integer, in this case we are talking about compatible types, because all of the values belonging to the integer also belongs to the long type. But in this case, the Roman type, it is F12, and 12 we can use to go to the definition. We can see that it's structure. It is structure. Therefore, how to distinguish the values? Because previously I asked you about what values are in the Roman type. It's not easy to answer this question because its definition is it's complex definition. So we have private part and public part, and there is some methods, additional method. In this case, the method plays special role. The methods play special role, but still, if you are talking about the type, we are talking about the set of operation we can apply against these values belonging to this type. From the private side, we can see only one variable, this field, In this language, we are calling it field, but in any other languages, always we can call it variable. Still, it's value holder. In this place, we are holding a value. We can assign here a value, and this value has type. It is limitation of the set of possible values we can assign to this variable. The private, it is prefix that means that it can be used only inside. It is against, it is according, not against, it is according to the encapsulation paradigm of the object-oriented programming. According to this paradigm, we can hide some values inside to be used only inside of the type. Here we have a type, and the value is we can use it only inside this type. But let's look in detail about this method. It looks like a method, but additionally it is static. Second, we have additional additional keyword implicit, and the most important thing is operator and type. Actually, it means conversion, because here we are not asking about the compatibility. So the Roman, it's not compatible with the integer. All the compatible files are defined inside of the language, and actually this rule can be applied to any language I know. So usually, if we are talking about the compatible type, all the compatible types are defined by the language as part of the semantics of this language. In this case, Roman is not compatible. But having appropriate operation on the Roman, here this operation is on the Roman, we can convert any Roman type into the integer. And converting, it means that here we can just return this value. The value is from this variable, therefore we can recognize this variable as a placeholder of the value. So this type defines the set of possible values we can use talking about this type, about the Roman type. So it is integer. At the end of the day, it is integer. Doesn't matter if you are if you are able to use all of the values. So if we can assign here all of the values, for example, minus values, but here we can see that it's convertible. We can convert the Roman into the integer. Therefore, it's possible to compare two integer numbers. Because let me recall the discussion about if the left sign is equal to the right side. Here we are checking if the left side is equal to the right side. If the value on the left side is equal to the value on the right side. But using the computer, using any machine, it is impossible to compare just a meaning. We must compare representation. Therefore, in any cases, if we are comparing something to each other, we are comparing stream of bits. Of course, the comparison must be executed by the processor, and the computer is binary machine. Therefore, finally, we must use binary representation, and we must compare binary representation. Sometimes the operation is complicated, but let me skip the discussion about all of the complication here. Here we can recognize that actually the Roman is integer. It comes from this operation. We can design So we designed the operation conversion of the value, that it's Roman value, into the integer. Here, for example, we can see also conversion from string to Roman type. Here we can see that the value is calculated because it is stream of characters. Go to definition, and it is complicated algorithm how to convert string into the number, into the integer. It is something like mapping, and there's many additional statement we are using to implement this algorithm. So it is, you can try to understand this algorithm, but actually it is not very important. It's something that you can find and just copy paste, for example, for this example. But for us, the most important thing it is that the representation of the Roman finally it is integer. It is integer here where I'm assigning the value after conversion. Therefore, get me back to this line. Here we can see that it is set of characters. It is a stream of characters. So let me ask if it's still a Roman number. Of course it is not. We are not getting the answer because it is correct string. It is correct string, but it's not correct Roman number. So, but we are not executing any operation. We are not trying to run this statement. Therefore, we are expecting to get a runtime error. How to prove that it's runtime error? From the previous lesson and for the next one, you will learn what the unit test. But here we can execute this. We can execute this test, and the result you can observe on the left side. So we must wait for a while. The result is over here. So we can see that the result is okay. So it works. But after changing this string to another one, let's run the test again. We are expecting that there is something wrong, and it is according to our expectation. The feedback from this machine, from this testing machine, from this testing environment, it's that yes, it's correct. But the question is, where is the error? Where is the error? It is very good, I think, for you use this option, not the run test, but debug the test. It provides some diagnostic information, and actually it provides a break where the problem is. You can see that we are here. Here it's key not found exception. As I said previously, always using the unit test, we must deal with exception. So in any case, if there is something wrong with the test, the problem must be with the throwing an exception. And in this case, we are throwing an exception because the key is outside of the map. The key is not expected. We can recognize what the key is. It is diagnostic, but let me skip it. For now, it's not very important how to use this diagnostic. Debugging machine debugging functionality, it's up to you to use it, but it's not required that you will be familiar with all of the function. It is very useful button to break the debugging and to get back to design, just to design the code of the program. But here we can see that is not correct text, but it's runtime. Is exactly the same as in this example, where we are getting runtime error. In all of the cases, the problem is the problem is with the conversion of the value. Therefore, the error previously said that there's a problem with conversion. In here, we are converting the string into integer, and it's impossible to convert it into integer. Therefore, it's impossible to convert it into an integer. Therefore, it is impossible to execute any operation. Additional error we can recognize here: it is impossible to run assignment because the value, for example, it's possible to convert it to the integer, but it's impossible to assign to the variable because the variable is limited, the type is limited. Okay, so it is, I think it's important for the next question, important for the task is, I'll try to answer the previous question, but now the question for you is, what is collection? Because the first task requires to use collection. But try to answer this question using the language terms, only language terms. Usually we can, for example, say that we are dealing with functionality. But we don't have this term functionality as part of the language. We cannot distinguish a construct that it's functionality. So we are talking about functionality of the part of the algorithm, and we must implement this functionality as something that we have in the language. Therefore, we talk in terms of the language, for example, statement of method or class or something like that. But let's get back to the simple type. We know that, for example, here we are dealing with simple type. What is the difference between the simple type and non-simple type? Opening this simple type, we can recognize, go to definition, that it's structure. It's not simple. It's complex. It contains many members. Therefore, we cannot say that it's simple, just assessing only by using the number of operations we have. Usually, each type is defined as something that is complex, but the type is the longest complex type. But the integer, the value, it's not complex. What is the difference? The difference is that we don't have, in case of the simple type, we don't have a selector. So we cannot distinguish part of the value, and we cannot select just a part of the value. All operation we can apply to the whole, to the value as one whole. Using the complex type, for example, string, go to definition, you can see that it's still, it is class. It's not structure, but it's class, but still it contains very members. Therefore, it's also complex as integer. But what is the most important for us? In this language, we call it indexer. But in any other languages, we could use different syntax, But usually in all of the languages, we can recognize operations that we can name selector to select just a one part of the value. Here, for example, let me go to the Roman type. Roman type, go to definition. No, okay, something wrong. Go to definition, not the base, go to definition. And here is an example of the selector. From the Roman map, from this, we are selecting only a part. From the Roman value, it is string, we are selecting just one character. In all of the cases, we are talking about the selector. Doesn't matter if it's complex. For example, here in the Roman map, we are talking about the dictionary. Dictionary is a class. Dictionary is a class. In talking about the string, we are also talking about the class. But in all of the cases, we are talking about the selector. The selector is different. The selector is different for the dictionary and for the string. So you can, as the homework, you can try to find the selector for the dictionary. There must be a selector in the dictionary that we are using to select only just one value. It still could be complex. In this case, it is complex. No, it is, in this case, it is dictionary of characters. So in this case, it is just one character. So we are getting one character from the value, and integer is just a key in this dictionary. So it is selector complex. But what is the structure type? Structure type, of course, it must be complex because we have appropriate selector, but property injection, where is this solution? Dependency injection. I'm trying to find an example. Instrumentation, no. Introduction, here. In this project, introduction, here we have Roman, is injection. Let me see where it is. Maybe it's in data semantics, sorry. It is next folder, data semantics, and here it is type concept, and for example, this type, it's segment. You can see that it's still complex. It is class. But we don't have here selector, so we cannot select just a one value. But in any cases, if we are dealing with values, we must apply any operation. We must apply any operation to this selected value. It is impossible, for example, to apply an operation to the something that is complex, because the computer works on the simple values only. But using the simple values and using the operation on the simple values, we can construct, for example, constructor, and we can organize the work with structure. But what the structure is? The structure is that we don't have we don't have selector, and we don't have structure. What the structure means? The structure means that there is a relation between the members. Here it is string, for example. Where is string? String, it's here. And for the string, we define that It is a set of characters. We can distinguish the first, the last, and the fourth. And for any for any other, we can distinguish the previous one and the next one. So it is a relationship between the characters, and this we are calling structure. In this case, the structure it's is just a sequence, but the structure could be a tree, for example. The structure could be a full mesh, where actually we don't have structure at all. It's dynamic. It is created during the runtime. So the structure actually it is constructed. We are not using selector, but we are using operation we call browse. And here, for example, we have a property that returns a segment as the result. Therefore, having access to the one element in this segment, we can get the next one. The same way we can organize trees and other segments, but in all of the cases we don't have selector, except we'll implement selector manually. Manual selector, you can structure okay, I think that we have discussed it previously, so let me skip it. Here you can find many examples that provides you more details about the selector, about the concept of the graph, about the concept how to join values together to provide appropriate relationship between the values. But for us now it is important some additional things. For example, a previous question was what the collection is. Let me find appropriate example. I am not sure about your answers, what the collection is, but here we have, for example, Roman type, and in Roman type we are using dictionary. How to prove that it's collection? Because during the assessing of your work, I will ask you how to prove that you are using collection, that it's collection. Always in this case, the very helpful is F12, because using F12 we can move to the definition. Here we can see that dictionary, it is just a class, doesn't matter what it means. We discuss it in a couple of seconds, but for us the most important is that it inherits, it implements iCollection interface. It is the answer. The collection is any type that inherits from iCollection. Sometimes we are not directly inherit from the collection, so the inheritance chain could be complicated. But on the end of the day, finally, on the inheritance chain, it must be possible to find iCollection interface, because it's so important. It is so important for us because using object-oriented programming and using the inheritance, we can derive the final functionality from the base functionality, from the functionality that is defined at the very beginning. In this case, for example, we can answer the question if it's possible to add to the collection at any time a new element, new item. So let's go to the definition for the iCollection. You can see that on the list there is add method. In this case, add method does nothing because it's part of the interface. It's abstract. It doesn't provide any implementation, but it says that the collection must provide an operation. Therefore, from the description, it is expected that at any time it should be possible to add new elements to the collection, new item, new entity. Of course, the type depends. Here we are talking about the generic types, so we'll discuss generic types in a couple of minutes, but still the answer for it is that we can, this way, we can define common functionality, common features of the type using this approach, using object-oriented programming, using inheritance. We can derive the new functionality. We can expand the basic functionality deriving from basic definition. So let's remember that collection is just any type that derive from the collection. Next question is, what is the layer? Previously we talked about the layers, and actually the layer it's required to be provided by your software. And to answer this question, we need to open. I'm pretty sure that I discussed it previously. Now it's just to check if you are following me. But the answer is adaptive programming. In this solution, we can distinguish something like layers. Because usually we are talking layer, we are describing layer as a set of functionality. But talking about the set of functionality, we are talking about the algorithm. But having the program, there's no impossible to talk about the functionality because this term is not defined in the language. In the language, we have interface, we have statement, we have procedure, method, things like that. Here there is a framework part, and actually I think that application architecture here we can distinguish this layers. So let me use a special tool that is used to convert the text of the program into the picture. It's very useful for us because here we can distinguish, we can see layers. It takes a while, so be patient. Keep smiling in the meantime. Still, software is compiling. Okay, now can I open it? No. Still no. Still it's working. Now it's possible. Still not. Hard work. It's not easy to convert the program into the diagram, especially if we are going to answer precisely some question. Now it's ready. So now we can see that here we can distinguish three parts. It is presentation part, business logic, and data. Let me recall that similar terms we used during the previous lecture describing the layers. So we have presentation layer, business layer, logic layer, and data layer. It is very important for you to have layers in your software. But what is the layer in this case? Usually we are talking about the layer, we are talking about the functionality. But talking about the language, in terms of the language, we are it's impossible to talk about the functionality. We must talk about, for example, namespaces. And actually here, the namespaces are used to implement the layers. And I think it's good approach, it's good advice for you to use the namespaces. In namespaces, we have type. So here we can see 3 namespaces. All the namespaces contain appropriate set of types, but the very important thing is that it's type, not only the class. Here we can recognize classes, but also we can recognize the enum structures and interfaces and many other types. The most important thing for the layers is that the layer above, just maybe I can use this to, it is possible to use it. Control F12. No. Okay, but this way I can draw. The most important thing is relationship. So let me recall to the question, what is the layer? Layer set of functionality, but the most important thing for this functionality is that the functionality use only the functionality from the layer below and only below. In this case, it is expressed by using of the types. So this layer provide here just a boundary of the layers. These layers, so the types use types from the layer below. It is exactly the same from this. This layer use only types that it's from the layer below. View layer, presentation layer use only types that belongs to the business logic, and business logic use only types that belongs to the data. It is required that you have the architecture like this. How to obtain this architecture, how to finally have this architecture is up to you. It's actually your task, your homework, but finally you must have something like this. It is also possible to have circular references in between your types inside just one library. For example, here, let me enlarge it. Okay. It is impossible to distinguish layers here because even if we put a boundary over here, for example, not sure if it's possible, over here or over here, we don't know. It is the rule that the layer above use only the layer below is broken here, because here we are using in the service C, we are using also the layer, the class service A, and in this case we are using from the layer below, we are using the layer above. It is against the definition. So let's get back, erase, and how to move it back to the typical zoom. Okay. Any questions to the layers? It's very important. So the next question for you is, can we use types? After that, try to answer this. Can we use types defined in the layer data in layer presentation? Can we use types defined in the layer data, in the layer the presentation layer. It should be presentation layer and data layer, but it's just a typo. Okay, what next? Next, it seems that now we should talk about the anonymous types. Anonymous types, it is over here. Let's close here and here. Don't save. I will return all of the modification because the code is in GitHub. So the very, very useful thing of the GitHub is that every modification could be reverted, could be so I could get back to the previous where it's I need here anonymous type unit test. Anonymous type unit test. It's also very useful here to use the search machine. Now we have anonymous types, and it is discussion about the Roman. So actually we can for example use Roman for assert and things like that. But here is the anonymous type. So for you, up to your homework is to analyze this unit test and try to learn more about the Roman types and in general about the custom types, about creation of the custom types, about possibility to execute any operation to construct an expression, what the expression is, how it works, what it converts. And now we'll talk about the anonymous types. For example, here we have anonymous type. So the question for you is anonymous type, let me put it on the chat, is anonymous type definition compliant with the type definition we know? It is also type. Let me explain this part of the code. Actually, here we don't have definition of the type. It's not here. Here we are defining, we are declaring, actually it's not definition, it's declaration. We are declaring new variable. And we are assigning, on the right side, we are assigning a value to this variable. Assigning new value to this variable, we must deal with the type of the variable. Here, the type, it is just a keyword that says that it's not defined, that it's something that could change. It says that it's var. It's something that is not it's not well known. But the question is if it means something that so let me ask you next question. Is var representation is var representing a concrete type? First, let me recall the definition of the type. It is set of values, well-known set of values. So, knowing the type, we need to know the set of values. Here you can see, for example, that we can compare. It is first thing. Second thing, it's about the type that we have. That we have well-defined operations of these values. From this line, we can recognize that the value is complex, because in the next line we are using a selector, just a dot. Dot is selector, so we are selecting from the value. We are selecting just a part, just one variable. Therefore, here we can recognize that this value holder is variable, and we can compare this variable to the number 108. So we have operations. The question is it is well-known set of operation. And what means actually this keyword? Let me uncomment this line. Here we are trying to assign to this same variable. So first we must answer the question if it's possible to change the type. For example, to put here long. Of course, it's impossible. It is we are getting an error. It is IntelliSense, but because we must run the compilation to get the full description of this error, but still the local variable is already defined. Therefore, in spite that here we are suggesting that something could change, here we must say that it's impossible to change the type. Doesn't matter what on the right side of this assign character is. Second, it's if we can change the set of possible values. Here I have changed the value of the amount, and now it is 108, but the syntax suggests that it's double. Let me return to the previous example when I tried to convert the integer into the double, and if the actually it was long and double, but here it's also doesn't matter what it is. If it's long of integer, doesn't it? It is. We can check it. Yes, it is. In this case, it's just integer. But I'm suggesting to convert the value into the float, into the double. Therefore, I'm getting an error because it's incompatible type, because the value could be outside of the expected values. Here it is not true, but now it's true. But only the I'm getting a message, but still we have a couple of minutes, so we'll continue. From this we can prove that in any case, that doesn't matter if the case it's that we are using correct values, that belongs to the allowed values, but only we are using other type of the expression, we are getting an error. So it means in all of the cases it means that it's impossible to change the type. Always the type is exactly the same, so the expected set of values is always the same. So it's not correct. In the next we can see something similar. The only difference is that I have swapped two fields, actually messages first and amounted second. Previously, in this variable, in this type, defined by the right side of this assign statement, the fields, the value holders are in a different sequence. First, here it was amount, but now it's message. So we can guess that type defined this way also depends on the sequence of the names we are using to name the value holders. Actually, these value holders are variables. So it is next very important feature of the anonymous types. In this language, we have two types of anonymous type, but let's discuss only this as a reference type, because also we have value anonymous type. It's up to you to learn more about it. But here, for example, we can also test if it's possible to change that just a selected part, to change the value of this variable. Anonymous variable, just a variable, and here I'm trying to assign to part of this variable, to part of this value, to assign doesn't matter what the value is. Here it could be could be any text, but in any case we are getting exactly the same result. It's impossible, therefore the value is only read only. So we have selector, we can select the value, but we can select the value, but it's impossible to change the value. It's impossible to replace the previous value by the new one. But from this line, we can guess that it is reference. It is reference type. It's not value type, because we can assign null to this value. We can assign null, saying that actually we don't have any value at all. So if the value exists, we cannot change the content of this value, but we can replace the whole value by null, by any other values. So the variable still, this variable still is variable. Still we can change the value of this variable, but we cannot change the value of this variable, of this we can change partially. We cannot change the contents of these variables. Okay, so here you can get more about the anonymous types and compatibility about these types. Why it's so important? It's very important here. It's value tuple, so it is still anonymous type. It works in a different way, but it is still anonymous type. We don't use the name. So the answer to the question, if it's concrete type, yes, it is concrete type, because only concrete types could be converted into an object. And here we are talking about the object. It is created by the new. It must be concrete type. The only difference between the concrete type and anonymous type is that anonymous types are concrete types, but without the name. Without the name. Only here we are using the keyword to replace the name of the type, to avoid the definition of the type, because we are defining the types, set the values, and set the operation using the expression. This expression, the syntax of this expression, that is on the right side of the sign character, defines the set of values and operation we can apply to these values. The difference comparing with classes or structures is that actually here we cannot modify the set of provided operations. All the operation, including selectors, actually we have only selectors. We don't have, it is impossible to define any custom method, because in this language we are the functionality, the operations we are editing are all the methods. So we cannot modify the set of operation, but still the set of operation is defined by the language for all of the anonymous types. It could be very, very important for the second task. Understanding what the anonymous type is very important for the second task. Here it is very important that still we are talking about the concrete type, but the only difference is that we are not using the name. So the question is, why? What is the reason that we need anonymous type? And I hope we will answer this question discussing some construct and discussing the task 2. Because in the second task, we are referring to the anonymous types. We are using anonymous types. And actually, it is very, very useful for us to use this construct because, and this is also your homework to answer the question, why it is so important? Because the only thing we have is a lot of limitation and we don't have appropriate name of the class. Any questions? Because I am going to go to the next topic. Partial class. What is partial class? Because it's still concrete class. Previously, I said that to create an object, we need concrete classes. It is impossible to create something that is concrete. I mean object from something that is abstract. It means abstract class or something that is not clearly defined. The partial class is recognized as previously for the anonymous types, recognized as the concrete type. It is concrete type. The only definition, the only difference between the class and partial class is the partial keyword here. So on the first question, I have answered the first question. So let me ask the second one. Because now we are talking about the syntax. What about semantics? What is semantics of the partial class? Because in the syntax, we can distinguish additional keywords here, and everything looks like expected for the class. Here we have partial class, and here we have also partial class. Next, it's partial. The class could have attribute. The class could inherit an interface. So everything looks similar to the typical classes we have in any languages. The only for us that ask questions that it's something that we must define. It's partial word, partial term, partial keyword. And next question for you, it is why we are, okay, first time I answered let's stop the discussion. Stop. What is the syntax? What is the semantic? Semantic is that there's two parts. There's two parts, this part and this part. It is one class. So actually, it is defined in two places. But before compilation, the text must be merged together to create one simple class. Therefore, we can talk about the partial classes as the concrete classes. Because in all of the cases, we must merge parts into one class, and we are talking about one class. Therefore, the most important thing is identifier of the class. we need the only one identifier, because, for example, it is possible to add this attribute. Of course, it's possible, but this attribute was added previously here. So we have two attributes. The answer is no, no, we have only one attribute because it's only one class, and adding attributes to the part of the class, it means that you are still talking about one class. So we must think about the class as a text that has been merged together to create one text that we can pass to the compilation. Therefore, it is very important for you. What is the reason? Let me ask this question. Why we are merging using partial classes construct but not repository? Because usually we are using repository to merge parts, to merge the code. If the code is prepared by one person and modified by the second person, so the repository we are using to merge the code, finally to have only one copy, one clone of the code on the local computer, and to apply any compilation process just to one code, to one program. But now it is, we are resigning. We are using something additional in the language. So what is the reason? You are trying to answer this code, but now I try to get to the next topic. It's also a very simple topic, therefore we don't need a lot of time to discuss it. No, it's something. Okay, yeah. Go ahead.
Before the laboratory classes, right?
We
had
oh
15-minute break.
Yes, you're right. So you are saying that the time is, we are out of the time, we must finish. Okay, so let's continue this discussion. Let me answer only the question that why we are merging, because we are using auto-generated code, and the auto-generated code is not our partner. It's something that happens on the same computer. Okay, so thank you very much. Let's get break before the next lesson. Thank you for your contribution to this lesson, and see you next week, or see you in a couple of minutes. Goodbye.